Write an exponential function that goes through the points 0, 8, and 220. If we're going to write an exponential function, we know that it's going to fall into the general form y equals a times bx. The fact that this point was not 0, 1 is what tells me that I'm going to need some multiplicative factor in front of the exponential in order to make it go through the point 0, 8. I'm scaling up that intercept from 0, 1 up to 0, 8. This is not an additive relationship. I can't just say plus 7 and move it up. Exponential functions require movement via multiplication, so we're going to need to figure out what that multiplication is. And it should be pretty straightforward. Knowing that the function goes through the point 0, 8, let's use those two coordinates and substitute them into the place of x and y. I know that b to the 0 because I know b has to be a non-1, non-negative base. I know that this is going to have a value of 1, which leaves me with a being 5, or excuse me, a being 8. Now that I know that a is 8, I can go back to the original function and make a equal 8, and now I'm at this point, but I still don't know what b is. That's where the other point comes into play. So we're going to substitute again, and if we do it correctly, we should be left with only one variable, and that variable being the b. Divide both sides by 8 and take the square root. I know I want the positive root because the exponential base has to be positive, so I know I don't have to mess around with 5 and negative 5. I can just say that I know my base is 5. So my final version of the exponential function is 8 times 5 to the x. If we want to be a little bit more precise, we'll throw that inside of parentheses. But if one of the points that you can identify is the intercept, if you know the y-intercept as one of the points, it becomes relatively simple to write the rest because that y-intercept is what tells you where to start.